seen substitution. Alright, so in this lesson, we're going to look at how do I solve a system of equations through elimination. So we've already seen substitution, we've already seen graphing, so this is the last method that we're going to look at. So it's called elimination because we are literally going to eliminate either the x variables or the y variables. And there's two ways that we can do that. We could either add the two equations together, or we are going to subtract the two equations in order to eliminate, like I said, one of the two variables. So if we look at our first example, we have x plus y is equal to 2 and x minus y equals to negative 10. So same as before, we're going to label our first equation and our second equation. And this system is kind of set up nicely for us because if I were to add both equations or if I were to subtract both equations, I would be eliminating one of the two variables. So both cases are going to work. So we're going to look at how what happens when I do it both ways. So first of all, let's look at if I add the two equations together, so equation 1 and equation 2. So just because I like to have my two equations set up against one on top of the other, so set up a line so that my x's are in the same row, my y's are in the same row, and my constants are in the same row, I'm going to rewrite my two equations. Okay? And again, I'm going to start by adding my two equations together. So what this will look like, I'm going to add the left side together and I'm going to add the right sides together. So if I take it term by term, x plus x, that will leave me with 2x. Y plus negative y, that's going to leave me with 0y. So the whole point of doing that was I was able to eliminate my y variables. And then last but not least, I have 2 plus negative 10, which equals negative 8. And I can solve this to give me that x is equal to negative 4. So by adding my two equations together, I was able to solve for my x value. Oops, sorry, that should be x equals negative 4. Alright, and then the same way we did with substitution, I'm going to take my answer for x, and I'm going to substitute it either into equation 1 or equation 2. In this case, it doesn't really make too much of a difference. So let's substitute it into equation 1, and I will have that x is now negative 4. So negative 4 plus y equals 2. I'll bring the negative 4 over, and I'll have y is equal to positive 6. So my solution set for this equation, my solution that I get, is the point negative 4 comma 6. So that is where the two lines intersect and which point satisfies both equations. Okay, so that was doing it by adding the two equations. Let's look at what happens, or what would happen, if I were to subtract these two equations from each other. So now I'm looking at 1 minus 2, and again, just because I like to have my equations aligned, I'll rewrite them. So x plus y equals 2, and x minus y equals negative 10. So be careful here. Now that we're doing a subtraction, I have to make sure that I remember that I'm subtracting each term from the second equation, or of the second equation. So I'll take it term by term. I have x minus x. That's going to leave me with 0 x's. So by doing this way, by subtracting the two equations, I'm able to eliminate now my x variable. So now y minus negative y, this is where we have to be careful. The minus negative y really means that I'm going to be adding the two y's together. So this is going to become y plus y, which equals 2y. And then on my right side, I have 2, again being careful with the negative sign, 2 minus negative 10, which is the same thing as 2 plus 10. So 2 equals 12, and I get the answer y is equal to 6, which is what I had solved for on the other, by doing it the other way, except for now I've solved for y first instead of x. So again, we're going to substitute y equals 6, and let's put it again into equation 1, doesn't matter. So that'll look like x plus 6 equals 2. I bring the 6 over and I have x equals negative 4. And again, I get the same answer that my solution set is negative 4 comma 6. So the only reason why I'm showing you both of these methods is because you are going to have to decide, depending on the situation, is it more advantageous for me to add the two equations or should I be subtracting them? So just a little bit of a note, I will add my two equations when I have that my signs are opposites. So I'm going to add when your signs are opposites. And I'm going to subtract when my signs are the same. And like I said here, I was able to, my x's had the same sign, I was able to eliminate the x's in this case. Okay? So let's go on, let's do another example. So example 2, we have 3x plus 2y equals 8 and negative x plus 6y equals 9. So before I'm even able to go ahead and add or subtract the equations, I have to look and see, are any of the coefficients of x or for y, are they the same? So I look, I have a coefficient of 3, I have a coefficient of negative 1, they're not the same. I have a coefficient of 2, I have a coefficient of 6, they're not the same. So I have to manipulate either one of my two equations or maybe both so that I end up with the same coefficients in front. So you have a couple options. I could, for example, take my first equation and multiply it by positive 3 to both have a 6y, or I could take my second equation and I could multiply it by 3 so that my x's are 3 and negative 3. Right? So it doesn't really matter which one you do. Let's take the second equation and I'm going to multiply it by 3. Okay, so this will look like I have 3 times negative x plus 6y equals 9. And just be careful here. Remember that if I'm multiplying an equation by some factor, I have to multiply each term by that factor. So this will turn into negative 3x plus 18y equals 27. All right, I keep going. So here is now my third equation I've created by rearranging equation 2 or manipulating equation 2. So I'm going to now rewrite my first equation, so 3x plus 2y equals 8. Again, I just like to have my equations aligned so that I remember what I'm adding and what I'm subtracting. And now, by multiplying my second equation by 3, I now have a coefficient of negative 3 for x and a coefficient of positive 3 for x. So hopefully you'll recognize this means that I'm going to add my two equations together to eliminate the x's. So negative 3 plus 3x is 0x, 18y plus 2y is 20y, and 27 plus 8 is 35. All right, and we can keep going. I have y is equal to 35 over 20, which reduces, if I divide both the numerator and denominator by 5, to 7/4. All right, so keep going. I have my answer for y. There's the bulk of the work, but I have to figure out what x equals to. So I will substitute y equals 7/4 into, let's put it in 1. Okay, so we'll have 3x plus 2 times 7/4, which equals to 8. Okay, so be careful here. 2 times 7/4 is the same thing as 14 over 4 or 7 over 2. So this becomes 7/2 equals 8. So I have 3x equals 8 minus 7/2. 3x equals 8 is the same thing as 16 over 2 minus 7/2. And this will become 3x equals 16/2 minus 7/2, 9/2. And then last but not least, sorry, we're running out of room. Let me move this over. Okay, so I have x equals 9/2 divided by 3. So just be careful here. I have a fraction divided by a fraction, which really is the same thing as 9/2 times 1/3. I take the reciprocal of the denominator. 3 is the same thing as 3 over 1. and this will simplify to 9/2 times 1/3 is the same thing as 3/2. Alright, so even though your answer was a fraction, doesn't mean it was wrong. It just, fractions are numbers too. Our answer was not an integer, that's all. So my final solution set, I'll say therefore x comma y is equal to, my x value was 3/2 or 1.5, and my y value was 7/4, or that is the same thing as 1.75. Alright, so there's my answer for my second example. Alright, last example that I'm going to do with you. So if I look at this one, it looks a little bit more daunting, probably because we have all those fractions, right? So 3/4 x plus 1/3 y is equal to 11/2, and 2/5 x minus 3/2 y is equal to negative 21 over 10. So before I start and I think of which variables do I want to eliminate, I'm going to clear my fractions, right? And I'm going to do that by looking at each one of my denominators. I have a 4, I have a 3, I have a 2. And I'm going to look, what is a number that is divisible by 4, 3, and 2? So essentially I'm finding the same thing as the common denominator. So 12 would be my common denominator between 4, 3, and 12. So if I take my first equation and I multiply it by 12, I'm going to be able to clear the fraction by doing that. So let's see what that looks like. So I'm taking 12 and I'm multiplying 3/4 x plus 1/3 y equals 11/2, like I said, by 12. And again, whenever we multiply an equation by some factor, I multiply every term. Alright, so my reasoning, why I did that, and again, this is the same thing as 12 over 1. So 12 over 1 times 3/4 gives me 36 over 4x. 12 times 1/3 is the same thing as 12 over 3y, and 12 times 11 is the same thing as 132 over 2. Okay, so now that I have that, I'm doing it out a little bit the longer way, but I hopefully can recognize, okay, 36 divided by 4, that reduces to 9x, 12 divided by 3, that reduces to 4y, and 132 divided by 2, that reduces to 66. So now this new equation is essentially the same thing as my first equation, just without any fractions. Alright, let's do the same thing to my second equation. So equation 2, I'm looking at my denominators. I have a 5, I have a 2, and a 10. Hopefully we recognize my common denominator, or what I'd like to multiply by to get rid of the fractions, is 10. So I'll take 10 times 2/5 x minus 3/2 y and negative 21 over 10. Okay, so 10 times 2/5, that ends up giving me 4x. 10 times negative 3/2, that's minus 15y. And 10 times negative 21 over 10, that gives me negative 21. Right, and here is my fourth equation. So now I'm comparing equation 3 and equation 4 together. And I'm looking at my coefficients. I have a 9x and a 4x. I have a 4 and a negative 15y. And I have to find some way to be able to get the same coefficients. So you have a couple options. You can either get it that you want your x's to have the same coefficients or your y's. I'm going to choose my x's. Again, it doesn't matter. So in order to do that, 9x would have to get multiplied by 4, and 4x would have to get multiplied by 9 in order to get the same equations. So, not done yet. We're going to take our third equation, and I'm going to multiply it by 4, and eventually I'm going to take my fourth equation, and I'm going to multiply it by, what did we say? We said 9. So that'll turn out to 9x times 4x. That's going to give me, 9x times 4, 36x. 4y times 4, 16y. 66 times 4, 264. Alright, equation 4 now by 9. I'm going to take 4x by 9. There's my 36x that I was looking for. Negative 15 times 9, 135, or negative 135. And negative 21 times 9, I'm going to get negative 189. And here is my fifth equation, sixth equation. And I'm comparing these two. My coefficients for x are the same sign. That means I need to subtract equation 5, and equation 6. So 36x minus 36x, goodbye, I'm done with those. 16 minus, and again, if it helps, put that negative sign in front so that you don't forget that you're multiplying that equation by itself. That is going to become 16 minus negative 135, which is the same thing as 16 plus 135, and I get 151y, and 264 minus negative 189, which becomes plus 189, 453, and all this work to reduce out y equals 3. So we actually end up with a pretty nice answer. Almost there, we've done most of our work, so we're left with substituting y equals 3 into either equation 1 or equation 2 or 3 or 4 or 5 or 6. So I'm going to avoid putting it into equation 1 and 2 because then I'm going to have to work with the fractions. It's fine, you can do it, but let's just kind of avoid that. And let's go with equation 3. So substitute y equals 3 into 3. So that'll look like, my equation 3 was 9x plus 4 times 3 now, equals, we said 66. So I have 9x plus 12 equals 66. 9x equals 54. Or x equals 6. And all that to get that our answer is 6, 3. And that's it. There's solving by elimination.